Okay, so we're trying to figure out this problem about path analysis and trying to help our friends decide on how they're going to do this Top Gun school thing. And so here's an example. So the first thing is the most important part is you have to know something about the variables you're measuring. You have to be able to look at and find, how might these things be related? What kind of model do we need to have? Then you draw it up and and that's kind of the step we're at. And so um, there's a box for an x. So an x is a variable that we're measuring that we think is something that causes something else, or is in that way. And then a y is a dependent variable. And usually we're going to have more than one x and often more than one y. And that's one of the cool things about path analysis and structural equation modeling. So here's the four variables we're looking at. We have this family variable with has to do with the person's family and what if they're from a military family or something like that. The need variable, and then we have the test variable that is the test that Charlie created that is supposed to discern whether they're going to be a good candidate for Top Gun. And then finally, dogfighting skills is what we're trying to predict. So that's kind of what we're interested in. So really, there's almost an infinite number of ways, or there's a ton of ways that you could create a model about using these four variables. One you could come up with, and this is called a fully identified or a saturated model. And this one you can see that every variable has a relationship with every other variable. It's called a fully identified model. And so you'll see we have 1, 2, 3, 4 variables, and we have 1, 2, 3, 4, 5, 6 relationships. And so, but that doesn't really help us very much because all that's saying is, okay, all these things are related. Now this, and so the squares are observed variables, and we'll have in structural equation modeling, if you see a circle, that's something different, and we'll talk about that. It's called a latent variable. We'll get to that later. And then you also have a relationship. These arrows are indicate a relationship. And then a curved line is a covariance, or just saying two things are correlated, and maybe not necessarily one has a direct effect on the others. They're just correlated. And so you'll see both curved lines and straight lines when you're looking at path analyses. So then you got to have a theory. What do we think? What do we think improves someone's dogfighting skills? And there's all these possibilities. And so, you have to know something about the variables. You have to find out, well, which one of these makes the most sense? This one has need, have an effect on the test, and have an effect on dogfighting, which maybe makes sense. But test not affecting dogfighting. Well, I mean, we developed the test for that reason. We might think that test does that, but that's a possibility. And then family have an effect on dogfighting, but family not having an effect on tests. I mean, we know intelligence runs through families, so maybe that's something that might need to be changed. Well, another model, and this is the model it seems like they might currently use, is when you have family and need have an effect on their test scores, that then therefore has an effect on dogfighting. And so you have no direct effects here to dogfighting, but they all kind of are mediated by this test variable. This other one is kind of a combination of those two, where both of these variables have an effect on tests, but then you also have need have an independent effect or a direct effect on dogfighting. And this one, all three of them have an effect independently on dogfighting. So you have to come up with a good model and come up with a theory. Then you can start somewhere. But if you screw this up, you may be flying a plane full of dog stuff out of Hong Kong, so that's a bad thing.